Visual perception. You're going to be shown some images. Please note if the object on the left or the object on the right appears closer to you. If neither of them seem closer, please note that. For this image, please take note of the number of the line that appears closer to you. The results. We showed these same images to 10 people. Here are our results. 7 out of 10 people said that the clearer object on the left appeared closer. How do you know that they are not the same distance away? 8 out of 10 people said that the lighter object on the right appeared closer. How do you know that they are not the same distance away? 10 out of 10 people answered that the object on the left appeared closer. How do you know that they are not the same distance away, that the shape on the right is not simply higher than the one on the left? This is our control. 8 out of 10 people answered that the objects appeared the same distance away. 10 out of 10 people answered that the object on the right appeared closer. How do you know that the shape on the left is not simply sitting on top of the shape on the right? 8 out of 10 people answered that it would be line number 1 that appeared closer. Why did they say this? Why do we see these results? In 1966, James Gibson proposed the theory that we use bottom-up processing in vision. He noted 6 affordances in this, noting specific cues in our environment that affect visual perception. They are optical array, the patterns of light that reach the eye from the environment, relative brightness, objects with brighter, clearer images are perceived as closer. Texture gradient, the grain of texture gets smaller as the object recedes, gives the impression of surfaces receding into this distance. Relative size, when an object moves further away from the eye, the image gets smaller. Objects with smaller images are seen as more distant. Superimposition, if the image of one object blocks the image of another, the first object is seen as closer. And height in the visual field. Objects further away are generally higher in the visual field. How do these relate to Bertin's visual variables? In most cases, there was no change in the size of the object. Only the value and position were changed. The line example shows how changes in texture can give us depth of field. And the superimposition example shows continuity. It shows how the brain closes the object that is hidden, assuming that it is rectangular in shape.